Hello everyone, welcome to this video. In this video we'll be looking at another property of our isomorphisms. So suppose we are given some group G here, right? For the group G we are considering some element n, which is some integer, and we are considering some element a present within this group G. Then in that case, here we have the property when the group operation is given to be multiplication. In that case, phi of, when we apply phi onto a to the power n, right, we would have phi to the power phi of a to whole to the power n, right? So that means taking the power first and then applying the mapping, or applying the mapping first and then taking the power, is the same thing when we have an isomorphism. Similarly, when we have the group operation as addition, in that case phi of n times a, this is equal to n times of phi of a. So that means adding a n times and then applying phi onto it, the mapping, or applying the mapping first and then adding it n times would give us the same result. As for the proof is very simple. In the first part, we wanted to prove that phi of a to the power n is equal to phi of a whole raised to power n. This is what we wanted to prove here. Now you can write, we can take this left hand side here and we can write phi of a to the power n as phi of a multiplied with a multiplied with a. How many times? It is total n times, right? We are doing this thing n times. So this is equal to phi of a, phi of a, phi of a, and how many times it is done? It is also phi of a, and this is performed n times. And why this is so? Because here, as this operation as phi is operation preserving, being an isomorphism, right? It is operation preserving, being an isomorphism, correct? So the proof is, you see, the proof is very simple. In the second case also we apply the same thing. We wanted to prove that phi of na, this is equal to n times of phi of a. This is what we wanted to prove here. So for the proof, if we consider the left hand side here, phi of na, we may write na as a plus a plus a. How many times? In total we write it n times, right? Now this thing is equal to phi of a plus phi of a, and so on. How many times? It is also n times. Why? Because again, as phi is operation preserving, right? And why it is operation preserving? It is because we have an isomorphism. So it is operation preserving, being an isomorphism, right? So therefore this is what? This thing is equal to phi of a raised to power n, right? And this is your right hand side. So this proves our second property. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.